Good morning, everyone. Myself, Monica Nancy Priya, Assistant Professor in the Department of Electrical and Electronics Engineering. In this semester, I'm handling W3017 Embedded C Programming in the Regulation 2021. In this session, we are going to discuss about the programming serial data transmitting. In this slide, we are going to study how the 8051 microcontroller transmit serial data. Serial communication means it's sending data one bit at a time through the transmission pin. This 8051 uses the UART communication for this process to transmit data serially. The microcontroller uses the registers such as TMOD, TH1, SCON, and the SBUF. These registers help in setting the baud rate, selecting communication mode, and transferring the data. So, what are the steps for programming the serial data transmission? Is first the TMOD register is loaded with 20H. How the TMOD register is loaded with 20H? This selects the timer 1 in mode 2, which is the 8-bit auto reload mode. Now the timer is used to generate the baud rate required for the serial communication. Next, the TH1 register is loaded with a suitable value depending on the required baud rate. For example, 9600 baud rate, a specific hexadecimal value is loaded to the TH1. Then the SCON register is loaded with 50H. This configures the serial port in mode 1. In this mode, the 8051 transfers 8-bit data with one start bit and one stop bit. It also enables the serial reception. These settings prepare the 8051 for serial communication. The next one is the starting transmission. How after configuring the registers, timer 1 is started by making the TR1 bit is equal to 1. This activates the timer and generates the baud rate. How the set to 1 that start the timer. Then the TI flag, that is the timer interrupt flag is cleared. Then the TI stands for the transmit interrupt flag. This it indicates whether it previous transmission is completed or not. Next, the data byte or character to be transmitted is loaded into the SBUF register. This SBUF register is the serial buffer register used for both transmission and reception. After loading data into SBUF, the microcontroller automatically starts transmitting the data serially through the transmission pin. This program continuously checks the how the TI flag when the transmission interrupt flag becomes 1, it becomes transmission as completed. If it in the 0, the transmission the before transmission the previous transmission does not completed, and the wait for the process to be completed. Next one is the what is the importance of the TI flag. This when a character is transmitted, the following operations takes place. First, the data byte is loaded into the SBUF register. Then the start bit is transmitted. After that, the 8-bit data is transmitted one bit at a time. Finally, the stop bit is sent. So once the stop bit transmission begins, the 8051 automatically sets the TA flag to 1. This indicates that the entire character has been transmitted successfully. The TA flag helps the programmer know when the microcontroller is ready to send the next character. This is the importance of the TA flag. Why the TA flag is important? The TA flag is very important because it prevents data loss. If another data byte is written in the SBF register before the previous transmission is complete, the part of the previous data may be lost or corrupted. The TA flag becomes 1 when the transmission gets previous transmission gets completed. If it is not completed, the bytes in the SBF register may be lost or corrupted. So therefore, the programmer must always check whether the TA flag becomes 1 before sending the next character. By monitoring the TI flag, we can ensure proper synchronization between the successive transmission and they avoid overloading the SBUF register. If we are sending the next character to the SBUF register, the SBUF register becomes overloading. If the previous transmission is not completed, then we have lost the whole content in the whole characters in the SBF register or corrupted in the SBF register. Next one is the clearing TI flag. The TA flag is automatically set by the hardware when transmission completes. However, the programmer must clear it manually using the software. This is done using the instruction CLR TA. This is the CLR TA. When the instruction CLR TA, if the TA flag is not cleared properly, when the microcontroller may incorrectly assume that the transmission is already complete, leading to the communication problem. Therefore, after every successful transmission, TA must be cleared before sending the next data type. Next one is the programming serial data receiving. This is how the 8051 receives the serial data. The data is received through the transmission pin before the reception starts, before the receiving starts. The RA flag is clear. The RA stands for the receive interrupt flag. The program continuously checks the RA flag. When the RA becomes 1, it means the complete character has been received. If the TA is 1, that is the transmission is completed, and the RA is 1, that is the receiving is completed. So the received data is stored in the SBUF register. The programmer must immediately copy the data in the another register or memory location before the new data arrives. What are the importance of RA flag? This RA flag indicate the successful reception of a complete character. The microcontroller first detects the start bit and then receives the 8-bit character, 1 bit at a time. Finally, the stop bit is received. After receiving the stop bit, the 8051 automatically sets R1 to 1. This indicates the programmer that valid data is available only in the SBUF register. The RA flag therefore helps the programmer know why when the data reception is complete. How will you know the data reception is complete? Yes, that the RA flag is set to be 1. So the RA flag is set to be 1. The all the receiving data, all the data overloaded in the SBF register should be received. That is the main theme of the RA flag. Why the RA flag is important? Another one is the RA flag is important because it prevents the loss of received data. Once RA becomes 1, already we said no, the programmer must immediately copy the contents of SBUF into another safe memory location. So after copying the data, the RA flag must be cleared using the instruction. How should we clear the instruction? CLR RA. If RA is not clear, the next incoming character cannot be stored in the SBF register, resulting in the data loss. So therefore, the program handling of RA is essential for reliable serial communication. So what is the doubling baud rate? The baud rate determines the speed of the serial communication. Higher baud rate means faster data transfer. So in this, we are having the two ways. First one is using a higher crystal oscillator frequency, and the second one is the setting the S mod bit in the PCON register. The PCON register is the 8-bit power control register. It contains a bit called S mod. Normally, when the 8051 is powered on, the S mod is 0. By setting the S mod to 1 through the software, the baud rate becomes double the normal value. The baud rate becomes double the normal value. This feature is useful when the faster communication speed is required. These are the references, and the PCON register is also having the responsible for the baud rate doubling, and the PCON register helps improve the communication speed without changing the hardware. And the references in the PCON register is also there. We will have see the next topic in the next video. Thank you.